first thing you need to do with stoichiometry is you need to have a balanced equation. So we've got an equation here. Take 10 seconds and balance it. Take 10 seconds and balance this equation. If you need some more scratch paper, there's more back at the back by the green crate. It is not.
It's not, see?
Oh, I have the time. Oh.
That would have been epic if R2 was actually in the classroom.
Okay, so balancing your C's, what do you need to do? There's 3 C's on the left, how many on the right?
3.
1, so you need to put 3. There's 8 C's on the left, how many, 8 H's on the left, how many on the right?
2, so 4.
So I need to put a 4 here. Oxygens, I've got 2 on the left, I've got 3 times 2 is 6, plus 4 is 10. So what do I need to put in front of this? 5. Okay, so balanced equation is paramount to do stoichiometry. It's sort of like your recipe. Okay, it tells you what the ratios are. So on this first one, and I am a very, very visual person, so I have to write underneath the equation what I have and where I'm going. So on the first question here, how many moles of CO2? Question mark, moles. So I know where I'm going to. Now I use a pencil because this is going to be used several times, so I'm going to erase underneath. Will be produced by the reaction of 1 mole of O2. Now I'm assuming that I'm going to have enough of the C3H8. Okay? And 1 mole of O2 is like I only have 1 egg in my recipe, my cookie recipe, and I've got to figure out how much of the rest I need. Okay, so I'm going to start here with your factor label, 1 mole of O2. And I don't want to know moles of O2, I want to know moles of CO2. So I'm going to use this balanced equation, the numbers in front. And for every 5 moles of O2, I put that on the bottom because I want to get rid of it, I get 3 moles of CO2, so I put that on top. Moles of O2 go out, and I take 3 divided by 5. Alright, let's take 3 divided by 5 then. That's what we need to do to get the answer here. 3 divided by 5 is what? One more time?
0.6.
0.6, and we would put moles of CO2. Circle or square your answer. Okay, next one I'm going to be a little bit different, so I'm going to get an eraser here and erase what's in the bottom here and erase my little green mark that told me what I was using. Looks like I need to fix my red. 5. Okay, on this next one I'll use blue so it doesn't come in. This one's asking me how many grams of H2O. So here I'm going to put a question mark and I'm looking for grams this time. And they say I have 1 mole of C3H8, which is propane. Okay, so start with what you have the number of. So 1 mole of propane. Start with your factor label. I want it, in order to use the equation, I have to be in moles, which I am. And now I'm going to look and I'm going to say, okay, what is the number here and the number here? That's my ratio. Which one am I going to put on top? 4 moles of H2O, because that's the one I want to get to. 4 moles of H2O. What do I put on the bottom?
1 mole of C3.
Good. 1 mole of C3H8. C3H8 moles go out. Am I to what I was trying to get to? No, I wanted to get to grams. I'm in moles. We've done to grams before. How do we go to grams? Remember the mole map. What are we going to put on the bottom here? What am I trying to get rid of? 1 mole of H2O. How do I find out how many grams are in 1 mole of H2O? Nope. Add up 1 oxygen, 15.999, and 2 hydrogens at 1.008, and what do we get? I've added that up so many times I know the answer. Okay, So now, all we have on the bottom are 1s, right? We don't really need to divide by 1. But on top, I've got a 1 and a 4 and an 18. So I'm going to take 4 times the 18 and get my answer, which is to how many significant figures? 1. Start at whatever I start with, that's how many significant figures I need in the end. So I started with 1, I only can have 1. So give me an answer to 1 significant figure. 4 times the 18. 70. Okay, good. 70 grams of H2O. Okay, so now I'm going to erase this again up here. And if I had a scratch piece of paper, I would just be bumping it up against this. Bump 24 there. Okay, so we're getting red on the bottom here. This time we're looking for grams of propane. But I have grams of oxygen, 3.2 grams of oxygen. Okay, so let's start with those 3.2 grams of oxygen. Before I can even use the balanced equation, what did I tell you I had to be in? I have to have it in moles. So I've got to change these grams to moles. So I want 1 mole of O2 on top. Again, to find the mass of O2, I'm just going to look on the periodic table and take 2 times 15.999. If I get lazy here, that's what I do, because I'm going to put it in my calculator anyway. Well, I put it in twice. Grams of O2 will cancel out. Okay. My next conversion here is going to be using the equation again. I'm going to be using the coefficient here and the coefficient here. Do I see that? That's my ratio. That's my recipe. So using the recipe, I want to get rid of oxygen, so I put that 5 moles of O2 on the bottom and 1 mole of C3H8 on top. Moles of O2 cancel out. Am I to where I want to be? Not yet. I want to get to grams. So the last step is going to be what? Grams to moles, or moles to grams. So 1 mole of C3H8 on the bottom. And this is where I grab my calculator because I've got to add up 3 carbons at 12.011 and 8 hydrogens at 1.008. Go ahead. Give me the answer. 3 carbons at 12.011 and 8 hydrogens at 1.008. Got a calculator right there. 3 times 12.011 plus 8 times 1.008. Okay, now on this one we have to be careful when we put them in our calculator because we've got numbers on the top and on the bottom. So we're going to times the numbers at the top through. We're going to hit our divide sign. We're going to put parentheses. We're going to times through the bottom. And we're going to close the parentheses and then hit equal. So plug it out through because we want to make sure everybody can do this. So times through the top. And you don't have to times by 1. If there's a 1 there, skip it. So 3.2 times 44.097. Then hit divide, parenthesis, and then times 2 times 15.99 times 5, close parenthesis. And then equal, or enter. What do we get? 0.88.
Is that the right sig figs?
Okay, is that the right sig figs? Yes, that 0 there just helps me to know that that's a decimal that I started with, in case I can't see it. We had 2 to start with, we need 2 to end with, we've got our answer. Okay, everybody got these written down, because we're going to switch to the next one on that page. Okay?
Answer, please.
I am going to put these up on the blog. I'll link it from the blog to YouTube, so if you need to go back over it, you can. Okay, next set. We're doing this set of problem right here. Okay. Okay, guys, pay attention. Come on, this is free points. This is the last one I'm going to do with you, and then I'm going to turn you loose to work on your own. So, first thing we need to do is make sure we have a balanced equation, do we? Yeah, we do. This is going to be easy because the ratio is what? 1 to 1. So if whatever one thing I have, I'm going to get the same thing. I still need to write it out, though. So on the first one, I start with 4 moles of sulfur. And I want to find out how many moles of sulfur dioxide I get. So 4 moles sulfur for 1 mole of sulfur. I get 1 mole of sulfur dioxide. Moles go out. And I had 3 significant figures to start, so I should end with 3. Okay, pretty easy. Okay, I'm going to erase again this little thing right here. I'm going to choose a different color. This time, we're looking for grams. So we're looking for grams of SO2, and we're asking how much would be formed if I had 8.0 grams of sulfur. Now yesterday said, well, how do you know you've got enough oxygen? Unless they tell you otherwise you have enough. We're not going to work with, they're called limiting reagent problems till later. So like how many peanut butter and jam sandwiches can I make if I have this much peanut butter, this much jam, and this much bread? Okay, so we'll work with that later. So how many grams? We're starting with 8 grams here of sulfur. Who can tell me your first step?
Yep. No, just kidding. Oh, do you have to change it to moles?
I have to be in moles before I can do a ratio, yes. So what do I put on top? What do I put on the bottom? 1 mole on top, good, because that's what I want to get to. And what do I put on the bottom? 32 grams of sulfur, good. Okay, so grams of sulfur are going to go out. 9 moles of sulfur. What's the next step? And I look here and here next. It's 1 to 1, so I can put 1 mole, I gotta change back, it's a different color. 1 mole of sulfur here to 1 mole of, what was I trying to go to? SO2, good. Moles of sulfur cancel. Still not there, what was the next step? I want to be in grams, so I've got to get rid of moles, put 1 mole of SO2 on the bottom. And on the top, I've got to add 1 sulfur's mass plus 2 oxygen's mass. Go ahead and add that and tell me what that is. So you're going to take the 32.06 and you're going to add 2 times 15.99. 64, that's about right. 60 what? 58. Okay, so you take 32.06 plus 2 times 15.99.
You do what?
Take 32.06 plus 2 times 15.999. Okay, that's what you should get is a 64.058. Then we only have 1 number on the bottom, so we can just take the top numbers and times them together, hit our divide sign, and put that bottom number in, and hit enter or equal, and we'll get our answer. How many significant figures should I report?
3.
3, yes.
15, no, 16.0.
16.0, good, grams of SO2. Okay, I'm going to raise up here again. And we are going to go on the next one. We'll do this one, make it blue. All right, how many grams of sulfur, so again, question mark grams, would be needed to produce 3.20 grams of sulfur dioxide? What do I start with? 3.2, good. So 3.20 grams of sulfur dioxide I start with first. What's my first step? What do I do now? What do I have to be in?
Moles.
Moles. So what am I going to put on top?
1 mole.
1 mole. 1 mole, SO2. What am I going to put on the bottom?
1 mole. That's 64.
The mass of SO2, we already added that up, so let's put it down there. 64.058 grams SO2. Save me a step because we use the same one. Grams go out. Okay, now, what do I do now? What am I trying to get to?
The
I go from moles to moles, right? Okay, you said circle, you were thinking of that. Okay, so for every 1 mole of SO2, because this is a 1-to-1 ratio all the way through, there is 1 mole of, what am I trying to get to? Sulfur. Okay, so moles of SO2 and moles of SO2 go out. Last step, what is it? Change it into grams. Good. So I'm going to put 1 mole of S on the bottom. And on the top, we've got new C's. Just a second, I'll tell you where you are. You get 32.06 grams of sulfur. Moles of sulfur go out. Okay. Where did we put you? David, you are right between Kyle and Kira. Kyra, sorry. Kyra. I've got a niece that spells it the same as she says it's Kira, so you're going to have to help me. Okay, so take your 3.2 times your 32.06, divide it by the 64. 1.6, is that enough significant figures? 0 grams. Okay, we need 3 significant figures. Okay? Alright, so I am going to let you work on the back side of this if you've got everything else done. You need to have your lab turned in by the end of today. It is worth 200 points, so you don't want to put it off. Okay? Make sure you've got those equations written. If you're having problems, come see me up at my desk. I have those 5 areas that you can set. Any other questions that you want me to go through or like to go through in front of the class? Okay. David, if you need a calculator, the white number on your desk, and you can grab the calculator out of the box. Okay?